in a triangle. So today we're going to go over medians and altitudes of triangles, and I'm just going to draw rough sketches, unlike before with our perpendicular bisectors and angle bisectors. We used a protractor and a compass. We're just going to draw rough sketches for these ones, since they're a little bit more involved with some problems here. So the first one I want to go over is a median. Okay, so the median of a triangle is a segment whose endpoints are at the vertex of the triangle and the midpoint of the opposite side. Okay, so it'll go from an angle of your triangle to the midpoint of that opposite side. So my drawings here, I know it's not going to be exact, but we're going to label it like it would be. So I want to go from angle A, meaning I need the midpoint of the side opposite that angle. So we're just going to draw on a midpoint. And I'm going to label it so I know it's a midpoint. And then we're going to connect that midpoint to that angle. Okay, and that would be a median of that triangle. Same thing in our second triangle here. We're going from this angle, so we need the midpoint of that side opposite. And again, we're just going to estimate here and then draw in our congruency markers so it is a midpoint. And then all we have to do is connect that angle to the midpoint of that opposite side. Last one, angle A is supposed to be this one right here. So we're looking at the opposite side, find its midpoint, label your congruent pieces, and then connect your midpoint to that angle.
Okay.
Not so bad?
No.
Alright, so just like with perpendicular bisectors and angle bisectors, if you draw in all three medians, you have a point of concurrency. Okay, that point of concurrency is called the centroid of the triangle. And I know you're doing stuff in POE with centroids. Yes, you are. Okay, so point of concurrency of all three medians in your triangle is called the centroid of that triangle. So that's what we're going to draw in here. And again, I know I didn't give you a protractor, just going to estimate, but since it is a point of concurrency, that means they all have to intersect in one point, right? Okay, so here I'm going to label my triangle first, ABC. I'm going to find the midpoint of each side. Okay, and then we want to connect that midpoint to that opposite angle. So A to BC's midpoint, B to AC's midpoint, and C to AB's midpoint. Oops, my paper moved. Okay, so they should all intersect about here. Okay, and again, that point is called your centroid. You doing okay so far?
Yes.
All right, so just like before, we have a centroid theorem. So we have a theorem about our point of concurrency. So the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So from your vertice to your centroid is 2/3 the distance of that entire segment. Okay, so from point A to this point, I'm going to call it point O. So from A to O, that's 2/3 of the entire segment. Meaning from O, if I label this M, from O to M, that would have to be 1/3 of that segment. Okay, so that means I have an entire segment. If I add those two fractions together, it'd be 3/3, one whole segment. So from your vertice to the centroid is 2/3. From your centroid to the side is 1/3. So if I have AM, okay, so my entire segment here, if I say that length is 33, how can I find OM?
Divided by 3.
Divided by 3. So OM would be what? 11. So if I'm given the entire segment, I can divide that segment by 3 to get the piece from the centroid to the side. Now if I have OM is 11, how do I find AO?
It's the 2/3.
Multiply 11 by 2. Okay, so 11 times 2 would be 22. Since this is split into 3 equal parts, there's 2 equal parts in this entire segment here. So I need 2 of these to fit in that section there. So I multiply by 2. Questions on that? We're going to do another example of that on the bottom there. So at the bottom then, in triangle CDE, so it's triangle off to the right, U is the centroid, okay, meaning all of these are medians of this triangle since U is the centroid. Now I'm also given UK is 12, EM, the entire segment is 21, and UD is 9. So before I even answer these 6 questions, what I like to do is just label all of the pieces right away. So if I know that UK is 12, and that's from the centroid to a side, how do I find CU? Times 2. So that would have to be 24. Okay, so whenever you're given from the centroid to the side, you need to multiply it by 2 to get from the centroid to the angle. Okay? Now here, UD is 9. Okay? That's from the angle to the centroid. So how do I find the length from the centroid to the side? Not multiplying this time, you'd divide. Okay, so I take 9 divided by 2. Yes, it's a decimal. It's 4.5. Now the last segment I was given was the entire segment of EM. Well, remember I did that in number 4 above when we drew it all in ourselves. I gave you the entire segment and I told you to find from the centroid to the side. So if this entire segment is 21, what would UM be? Seven. Okay, I took 21, divided it by 3 because that segment is split into 3 equal parts. One of those equal parts would be UM. Okay, then to get UE, I'd multiply 7 by 2 and that'd be 14. Or you can think about, take 21 minus 7. Okay, because you need the rest of that segment and you were given the whole one in the first place. Okay, does that make sense?
Yes.
Okay, now that I have each of those pieces labeled, I'm going to go back and answer these questions. So number 6, we want to find CU. I labeled CU as 24. Number 7, MU. Labeled that as 7. CK, so this entire segment, I need to add 24 and 12 together. It is 36. Then JU, right here, labeled as 4.5. We did that by dividing 9 by 2. Number 10,
14.
EU is 14. Okay, that's 2/3 of 21. And then JD, so I need to add my 2 pieces together here. Okay, questions on how I get each of those measurements in those segments? No, we're good? All right, then on the back, the next one I want to go over is an altitude. Okay, so this is another special segment drawn into your triangle. The altitude of the triangle is the perpendicular segment from a vertex to the opposite side, or to a line that contains the opposite side. So it's not a perpendicular bisector. It doesn't need to go through the midpoint of that opposite side. It's just perpendicular and through the vertex. Okay, so these are all different. Now, to draw these in, I want to go from angle A, so that'll be my vertex, and then I need it to be perpendicular to that opposite side. So that means it has to be 90 degrees with this opposite side here. So again, I'm just going to estimate to make that 90 degrees. Okay, it doesn't have to be at the midpoint. Just perpendicular to that opposite side. Okay, we're going to do the same thing here. From angle A, we want to go to the side opposite that angle. Now for this one, it lines up along one of the sides, because this is a right triangle. So if you have a right triangle from your vertex to that opposite side, it could lie along one of those sides. Okay, the last type, I didn't write this one in here, but if I have an obtuse triangle, right? So draw an obtuse triangle, and I'm going to put angle A up here. To draw in an altitude from this angle, I can't draw it in where it's going to hit over here at 90 degrees, right? Okay, if I keep going this way, it's going to keep getting smaller. However, I can extend my bottom line right here. Okay, and then my altitude would end up being outside of my triangle. Okay, so your altitude can be on the outside of that triangle. Drawn it on the outside. But that's for an obtuse triangle only. Okay, acute, it will be inside the triangle. On a right triangle, it'll be on the right angle. And then obtuse, it'll be outside. Questions on that? And again, I won't ask you to draw in an altitude on a quiz or a test. There is a way you can do it with a compass, but we're not going to do those. Okay, so just like with every other special segment in our triangle, we have a point of concurrency. Okay, so the lines containing the three altitudes are concurrent. The point of concurrency is called the orthocenter. Okay, so this is your point of concurrency for all three of your altitudes in a triangle. Okay, so now you have a circumcenter, an incenter, a centroid, and an orthocenter. Okay, so we want to name the point of concurrency for each. So the three altitudes, what is their point of concurrency? Orthocenter. Three medians, what's their point of concurrency? Centroid. Three perpendicular bisectors.
Circumcenter.
Good job. And then the last one, the angle bisectors, is the incenter. Okay, so you do need to know that. So yeah. So much vocabulary in geometry. You need to know what these are, okay, and be able to match them together. All right, so in that next section there, I'm going to draw in these special segments, and I want you guys to label them correctly. Not with their point of concurrency, just what type of special segment is it? Is it a perpendicular bisector, an angle bisector, a median, or an altitude? Okay, so I'm going to draw those in. Don't yell it out either, please. Just draw them in, and then underneath, write what type of special segment that is. How was my night? Last night? I went to go see a movie.
What do you have for dinner?
Wait, was it the Bohemian Rhapsody?
Applebee's.
Was it the
That's good.
What movie did you see?
Bohemian Rhapsody?
Fantastic Beasts.
Was it good?
Was
Yeah.
it good?
Yeah?
Oh, shoot.
Did you go
Wait,
with
did you
your
answer my
husband?
question?
Yeah.
Dark popcorn?
I didn't get any popcorn because I went to Applebee's right before.
What did you say?
Even if you eat before you die.
It's
Oh, the second one? Was it good?
Yeah.
I kept asking if it was the Bohemian Rhapsody, but she wouldn't answer me. And
I told you what I
I
said.
couldn't hear it.
That's because you can't hear over you talking. Yeah.
Mm.
Okay,
I
so
asked them first.
letter A, what type of special segment is that?
Median.
Medium.
I thought that
I
was
think they look
median.
worse.
Like, I thought we had to go off like the
Okay, so letter A is a median. What's letter B? It
altitude.
Altitude.
is an altitude. What's letter C?
Perpendicular.
Don't forget bisector.
Okay.
What's letter D then?
Bisector.
Okay.
That's right.
You do need to know how to do this for your quiz. I don't think I told your class. Your quiz will be when you come back from break, not the first day. Okay, you'll be doing a review the first day you get back from break, and then the quiz will be the day after. Now, the
That's
quiz
wrong.
is not that long. It's really short.
Like,
And a lot of it is matching. So what type of special segment is this? What is the point of concurrency of all your perpendicular bisectors? Stuff like that.
So it's matching. So I don't know. Making snowman.
Making snowmen.
guys, let's continue with the worksheet.
We're almost done. So the last question I have on here is to compare and contrast the perpendicular bisectors, medians, and altitudes of a triangle. So you need to compare and contrast perpendicular bisectors and medians, perpendicular bisectors and altitudes, and medians and altitudes. So 3 different things there that you need to compare and contrast. So honestly, you can do 3 sentences.
They all have different names.
Not like that. The segment itself drawn into a triangle. Talk to each other, whoever's around you, how perpendicular bisectors and medians are the same and different. Medians and altitudes are the same and different. And perpendicular bisectors and altitudes are the same and different.
We're leaving school in December, right?
And then we're coming back.
In January. Yeah.
Holy cow.
Good job, Kenzie.
I'm just waiting for people to talk about the joke of see you next year.
Yeah, I was gonna say.
See you next year.
Shut up.
You'll still see each other until Friday, but it's fine.
Yeah, I want to say I'm trying.
Next year.
This is all money. On Friday, say no only for the rest of the year.
Yep.
I'll add my socks
That's
on.
terrible. What else did you got? I did.
For what?
For what? No.
Wait, what is
Okay, so we're doing this now?
You're doing the last question. Hey. Shh. You should be talking about this last question or writing down your response.
I wrote it down already.
Oh,
What's the points? The game.
We have like Juneteenth.
I wrote a lot, FYI.
same. What a loser. Oh my gosh.
I'm just.
Oh, you can write 3 sentences, not like a paragraph.
You want to keep that there for me?
It was 3 sentences.
No way.
It's
They're
3
They're
sentences.
not structured well.
Yeah.
They're fine.
Terrible. Mr. Duffy.
They're not. So, okay. Shh. Perpendicular bisectors and medians. Both pass through the midpoint of side. Okay, that's how they are the same. Differences. Only the median always goes through the vertex or that opposite angle. Your perpendicular bisector does not need to. Comparing perpendicular bisectors and altitudes, both are perpendicular to a side. Okay, they both create that 90-degree angle. But an altitude always has to go through the vertex. Your perpendicular bisector does not necessarily have to go through the vertex of that opposite angle. Okay, and then your median and your altitude both pass through a vertex. Okay, so those are the two that have to pass through an angle. But the altitude does not necessarily pass through the midpoint of the opposite side. It could pass through the midpoint, but it doesn't have to. Okay, the only way an altitude passes through the midpoint is if it's equilateral or isosceles from the vertex angle. Does that make sense?
Yeah, just keep that up there for a while.
Oh, I will.
You're writing that all down.
Do you have any Christmas parties you're going to this fall?
I have my family Christmas parties. Oh, I do have one with my friends next week, Friday. That one's in Madison.
Is that like Wednesday?
Christmas
Tuesday.
around next Tuesday.
That's fun.
We're close.
So Christmas Eve is on Monday?
Yep.
Hey, wait. So can we make a list?
The
for,
only
like,
reason
food
I know
Friday?
that is because Christmas Eve is always the same day of the week as my birthday. So my birthday was on Monday, so Christmas Eve is on Monday.
Oh,
That's
happy
kind of
April.
cool.
Yeah.
Hey, wait. Can we make a list for like food for Friday?
Yeah. But at whatever day of the week my birthday is on, Christmas Eve is on that day of the week too.
What, like, day is your date?
The 12th of
And Alex
November.
bring you a cake for your
Yes.
birthday?
You gonna talk
I
about it?
didn't eat any of it.
Alex, who?
Burton.
He's kind of creepy.
Okay, so the other 2 sheets I gave you, one of them is your homework assignment. That's the blue sheet. The other one is a graphic organizer, okay, of all 4 of our special segments in our triangles. So, looking at that, can I take away my
No.
papers yet?
No.
But I have to put this up on the board.
Wait.
No,
10 more, wait.
please
20
take
more
it away.
seconds.
Take it away.
Connor, did you do, like, my writing?
I don't think so.
Not, like,
That's terrible handwriting.
he was just waiting to do yours.
Yep. So I'm gonna put something up on the board.
Wait. 5, 4, 3,
Connor.
2, 1. Okay, I'm good. Stop.
Okay, so I'm going to put this up on the board and it's going to help you. So this is your perpendicular bisectors with the circumcenter. That's that first one on the left. So you need to write out what is the point of concurrency on that first line. Okay, you should write circumcenter on that first line. The location of your point of concurrency in an acute triangle. That's what I have on the board. Where's that point of concurrency?
Inside.
Inside the triangle. So you're going to write inside the triangle next to that acute triangle.
Inside.
For an obtuse triangle. This is an obtuse triangle. Where is your point of concurrency?
Over there.
Outside. Okay, so your point of concurrency will be on the outside of your triangle.
Inside, right?
Rudolph.
This is the right triangle.
Inside.
It's on the hypotenuse. Okay, so for where it says in a right triangle, this is where your point of concurrency lies. On hypotenuse. Okay, and then the last one in that box is this is the center of what type of circle? Do you remember?
It's not the inscribed one.
No.
It's the other one.
Circumscribed.
Connor.
What?
Yes. Okay, and then for your triangle, oh, I forgot I have this up.
I almost started writing that before because you said it.
Okay, for your triangle, you do want to draw in that special segment so you know what it looks like as well. Okay, you can draw in all three so you know where the point of concurrency is and what that looks like if you want, but one is fine, just to have that drawn in so you know what it looks like. Okay, we're going to do the same thing for all of these. I'm not going to tell you where each point of concurrency lies, though. You're going to just look at the triangles I put up on the board. So I'm going to go across to the angle bisectors. Okay, so first, again, write out your point of concurrency. What is it called? It's actually up on the board.
Incenter.
It is the incenter. Okay, I'm going to change my triangle.
Oh, inside.
Okay, so write out where that point of concurrency lies. So what is the location of your point of concurrency?
No, it's just kidding.
Is it this inside triangle?
Inside for all of them?
And then this inscribed.
What? Wait.
Yeah.
It's the center of what circle?
What?
It's the center of what circle?
What?
Can we still finish our other assignments?
Sure.
But does we do by tomorrow?
Just have them done by Friday.
Okay.
Wait.
Yeah.
Why are we doing this?
So that you have this nice graphic organizer so you know where everything is.
Wait, like, can't use the.
No, Connie, you can't.
All right, this one's for your medians.
Midpoint of opposite side.
Wait, what?
What's the point of concurrency in all your medians? What's it called? Yep. It's a centroid. Now I'm going to move my vertices here, and you're going to watch this point of concurrency.
It's on the inside.
Yep. So where's the location of your point of concurrency for all of your medians? That's what you're writing in that blank space with the question mark there.
Right inside?
Mm-hmm.
How come they're different?
What?
Those listed out versus in the question.
Because these ones, no matter what type of triangle I make, it's always going to be inside. No, it's not the center of any circle. It doesn't have the center of anything for that one.
Oh, we were going down.
All right, this is your altitudes. Okay, so again, first, write out your point of concurrency of all your altitudes. Okay, this one, I'm going to make, okay, this is an acute triangle. Okay, so where it says location of point of concurrency, this one is your acute triangle. So where is that located? This one is obtuse. Okay, and then this is the right triangle.
It's like on
It's on the left.
the opposite.
It's on the right angle of your right triangle. So right now it's on point B here. So it's on the right angle of your right triangle.
This is some music.
That's all of them.
Wait, for angle bisector, in the center of an inscribed circle?
Yeah.
Okay, cool. Wait.
Okay, so I did want you to have that graphic organizer just because it's a little bit easier to see what segments what when you're studying them. And then you also have the points of concurrency written out for each of those too. But again, make sure you draw in that special segment in that triangle so you also know what it looks like. Okay, so if you didn't do that, draw those in as well. Okay, then the rest of the time I do want you working on